Hi, Ashish, can you hear me?
Hi, yes, Sudhir. I can hear you.
Okay.
There.
Hi, Udyan, can you hear me?
Yes, I can hear you. Yeah. I think Rajesh has
Okay.
already joined, right?
Yes, I think so. I can't. Rajesh, sir, have you already joined?
Yes, I have joined.
Okay. Uh, Rajesh, we can't hear you. Can you be a bit louder?
Okay.
Please,
Hello.
Rajesh. Hi, Rajesh.
Hi. Yeah. Join.
Okay, hi. You can,
Yeah, I can move. One another both.
okay, your
Okay,
voice
thank
is
you.
slightly muffled.
Still, it is. Is it better now?
Uh, would you like us to show any slides or any video now before we start our session?
Yeah, but, should I present the screen? I think. Yeah, just hold on.
Or then maybe you can help sir with just his slides. I think he wants to just check on his slides.
Yeah,
So,
Rajesh,
shall I? Or
yeah, you
do
might
we
want
wait?
to share your slides and test out if there are any videos with you. So just check it out and share your screen. Yes, I can see your screen. Perfect. The slides.
Yes, we can see your screen, sir. Is there any video you would like to test?
Yeah, I'll just start with the video and then start with the presentation then after that.
ये तो मैं ऑफ ऑन कर रहा हूँ.
Good evening, sir.
Good evening. Good evening.
Good evening. I think we are just trying to figure out the video running and everything.
No
The
problem.
testing is done.
Go ahead. I'm
Rajesh, sir.
keeping
Okay,
myself
sir.
mute.
Okay, sir. Rajesh, sir, are you okay? So should we start with our talk for today?
Yeah, I'm ready.
Okay. Okay. Wonderful, wonderful. The brief, just to tell you how the format flows out, sir. It is first we play a few videos, which is basically to introduce people to Cobotalks and the whole idea of Cobotalks and what IHFC is all about. And then after that, I will briefly introduce you and your topic, and then I will hand over the platform to you. That's the way the talk is going to proceed. Okay? Okay?
Okay. Okay. Yeah.
Okay, thank you, sir. Udayan and team, could we please have about Cobotalks as well as about IHFC played right now?
Yes. Ashish, go ahead.
Welcome to Cobotalks, a monthly seminar series. Second Wednesday every month since 14th October 2020. 20 plus speakers presented on Robotics. Our collaborating partners: IHFC, BIRD, Cognitive Science Program, a Department of Humanities and Social Sciences. IHF Foundation for Robotics, Technology Innovation Hub of IIT Delhi, a national mission on interdisciplinary cyber-physical systems by DST, Department of Science and Technology, Government of India in March 2020. A Section 8 company, IHF Foundation for Robotics, IHFC, was incorporated on June 13, 2020. About IHFC. Advances in sensing, computation, and autonomy are enabling robots and autonomous systems to enter real-world domains such as manufacturing, defense, medical, agriculture, etc., where machines must work alongside and interact with humans. We are entering an era of manned and unmanned teaming where humans and robotic systems must work together towards common goals. The four verticals of IHFC: medical, agriculture, industry, and defense. Our goals: human-robot collaboration for enhancing human capabilities and reducing risk and improving productivity. Our objectives: research on novel technology areas of robotics and automation science, development of products for benefit of society, inculcation of startups, and promoting entrepreneurship in India. Our CQ: concept, collaborate, commercialize.
एक ही है ना
From research to product.
हाँ
Grand projects of IHFC.
Yeah, Ashish, we lost the audio in between.
Volume. There's no audio.
Inspired robots and drones.
Yeah. We can hear now.
The Center of Excellence on Bird, Biologically Inspired Robots and Drones at IIT Delhi is an evolution from its humble research activities, which began a
Rest, can
few
you please
decades
mute
ago by
yourself?
its faculty drawn from the Department of Mechanical, Electrical, and Computer Science Engineering. Bird has 10 plus projects, industrial and academic, 27 plus members including faculty, students and technical staff across various departments of IIT Delhi, 150 plus publication in international and national conference and journals, 9 years of experience. Cognitive Science Program, a department of humanities and social sciences at IIT Delhi. Cognitive Science Group at IIT Delhi is to create a knowledge pool that can address relevant problems under the ambit of human cognition both for India and the world at large. It helps students acquire a strong background in theoretical frameworks and empirical approaches of one or more areas of cognitive science. Cognitive science is an emerging new field of study that endeavors to study the mind from multiple perspectives and disciplines by combining ideas, principles, and methods from psychology, linguistics, philosophy, computer science, and neuroscience. This knowledge is applied for developing a better understanding of how our minds, brains work while creating better products, tools, services and policies. Cobotalks, leading the way in the human-robot collaboration space. IHFC.
Thank you. Yeah, could we have the IHFC video, please?
See, everything is gonna change. Whatever you look around yourself, I think everything will change. All these technologies, they are going to be very, very significant in our life.
We envision that we are going to use robotics and humans and the human-robotic interface for improvement of society.
That our focus should be human-robot interactions. Human-robot interaction means that human intelligence with robot's precision. We are called Cobotics. Cobotics means collaborative robotics, where human beings and robot work together.
We work on technologies of the future. We look at ways in which these technologies will actually get deployed. We provide leadership in this. We work with industry.
So we have chosen 4 major thrust areas, we may call it. One is called the medical robotics. The second is the defense robotics. Third is the agriculture robotics. And fourth is the industry 4.0 or industry 5.0.
We are trying to build an ecosystem here. When we talk about ecosystem, it starts from the kind of research capabilities that we are able to build. How is that we are able to instill the sense of commercialization in all those activities. We should talk about how is that research getting translated into products. So I think we want to be that ecosystem, we want to be that enabler which is making that possible.
We've also got a large number of research projects and technology development. We are also creating some common infrastructure, for instance in the area of medical simulation, in the area of drones, which can be used by a whole group, so that we are trying to create an innovation ecosystem in the field of cobotics.
Some of the research, for example, prosthetic hands done by Tezpur University, the professor tells that it is undergoing field trials with the doctors. So that's a kind of a positive that it is reaching towards the markets. Coming to the startup funding, we are very happy that one of the startup companies from IIT Delhi, Botlab Dynamics, whom we funded last year, they could show 1,000 drone swarming on 29th of January last year, which made the country 4th in the world. So that's a pride on us because we have been contributing to that part.
What an industry can offer, an academia can't. What an academia can offer, industry can't. If we all come together, that's the real value proposition for a startup. So I think that is what we are trying to build through a collaboration.
Mission of IHFC and the mission of IIT Delhi, there's a lot of synergy. And so we are treating IHFC as an extension of the things that we anyway want to do. So we've been supportive in terms of our students, our researchers, our admin and our infrastructure. We also have our faculty members writing proposals, and so some of the projects done by IHFC are actually implemented in our institute.
So we would like to see it as a global company. And when I say a global company, it's a research aggregator, actually, the way we have structured ourselves.
When we talk about DTP or MCC or READY program, these are some of the initiatives, when we are talking about students who have an intention to work in the domain of research and development, they need to be supported. They have still not made up their mind as to, if they are going to start a job, they are going to start a startup, they are going to work a little bit more in terms of, whatever they are passionate about. We want to give them a platform, and that is what READY is all about.
Then we are creating 2 specialized centers, which we call Medical Robotics Center. It will be done in collaboration with IIT Delhi. The second one is the Drone Technology Park.
And the reason we have selected Sonipat is that it is away from this red zone. So it's an easy place to test. It's an easy place to bring everyone together. So we want to create an ecosystem for testing, manufacturing, research and development, startups, incubation, training, all these put together in that space.
The first goal of success would be creating an impact in society through some value add in terms of technologies and ideas.
I would definitely want IHFC to make an impact, an impact wherein we see our ecosystem coming together to see that we as an entity, we as a country, we as an ecosystem are able to build products on our own. And that is what we want to do as a part of IHFC.
Thank you, Udayan and team. And a very warm welcome to you, sir, Mr. Rajesh Kumar. It gives me great pleasure. I'm Priya Basu. I'm the head of marketing with IHFC. And it gives me indeed great pleasure to invite you and welcome you today to our 41st, actually, Cobotalks. I mean, we have been having Cobotalks since 2000, and now we are in almost 4 years down the line. This is our 41st one, and we are so honored and privileged that you have joined us today for this wonderful talk. And in today's talk, of course, Mr. Rajesh Kumar is going to talk about Addverb, what is happening, basically the future of modern robotics in Addverb, and how he merges planning, perception, and control all into one. Mr. Rajesh Kumar is, of course, a leading expert in R&D with Addverb Technologies itself, and he holds an extensive experience in not only just software but also intelligent modules for legged robots, collaborative arms, haptic devices, and sir also has many published, like 30 published paper under his hat as a feather to his cap, and holds over 12 patents. With that kind of an illustrious background and experience and rich knowledge to share with, I think Sir Rajesh sir is going to give us a delightful talk, which we are going to learn a lot from. So welcome, Rajesh sir, once again, and I hand over the platform to you. Once again from IHFC, thank you for joining us today. Handing over the platform to you, sir. All yours.
Yeah. So thanks a lot for the introduction. Is the screen visible?
Yes.
Yes, sir.
So, good evening, everyone. As ma'am said, today this talk would revolve around, obviously, it's robotics, a little bit about Adverb and what we have been doing and what we are planning to do in the future. So I'll tell you a little bit about Addverb Technologies. So Addverb Technologies is basically robotics and warehouse. We started as a robotics and warehouse automation company. Started around 2016 in a very small location in Delhi, and then from there now it's been 8 years, and like it started as a warehouse automation thing and then expanded globally. Now we have presence in Delhi, which is Noida, an R&D center in Noida, a dedicated manufacturing facility in Greater Noida, and then sales offices across India. We have presence in Australia, Europe, and the US, and we have got an R&D center in Fremont in the US and an R&D center in Noida, where I'm sitting right now. So although we started as a warehouse automation company, and we have been deploying projects ranging from conveyors, racks, mobile robots, and all. Now we have started expanding our horizon where we want to get into other regimes, including like collaborative robots, legged robots, and like medical robotics and all. So I'll give you a brief introduction of what we have been doing uh, and what we are what lies ahead in the R&D domain, basically. So this is a small video which introduces one of our new factory, which we call as Botverse. The R&D facility is called as Bot Valley. So yeah, I'll just play a video.
Rajesh, the sound is quite low. Can you check it once?
Okay.
Audio, yeah. And you can press on the height that is there. That is a.
So I'll tell you a little bit more. In Adverb, we do the complete thing. Means we have our own mechanical design, we have our own software, embedded, and production facility as well. So we procure motors and we procure like raw material, and we do everything in house. So this is I think one of its only factory or an R&D center in India, at least in the robotics domain, who do everything in house. So, so these are the tag-based mobile robots that we develop. They are like for the use for sortation purposes. They can like multiples of them, like hundreds of them, can sort items, take certain items from one conveyor point and then sort it and then send it to another for dispatch. So this is for quick sorting for retail warehouses where quick deliveries are desired. So this is another. I'll just get back to this point. So this is another mobile robot which we call as a Dynamo series. So the previous one was based on tag-based navigation, where it's like there are tags placed on the ground, so it will move to one point and orient itself and then move to another point. These are based on natural navigation, as they call SLAM, which is simultaneous localization and mapping. So they do not require any tag on all. So they can be lidar based or camera based. And then you just create a map of the environment, give the goal trajectories, they'll move and do the task. And we also have a fleet management system. For example, this is one of the robot. What if we have to control 100 robots to do a task, 200 robots to do a task? So we have our own fleet management system which has optimization based routines, so that which robot should move, where should it place, how it should go. There should not be enough traffic. Means there should not be like some robots are sitting idle, some robots are doing most of the work. So all these things are taken care of. So these are mother-child systems. So these are not classical. These are more like, these are not modern robots. These are more classical, where they move on racks. They take an item, uh, put it into some other area, and then are you basically used to put items on a stacker on a rack, and then extract item whatever is required. We also have our own warehouse management system, where from the software you just locate okay which item you want, and these systems will just extract it for you. So we although it started as a startup, but now we have, like as I said, we have presence across all the continents. So we are I'm sitting in India, we have Addverb Europe, we have Addverb US, and globally we have around 1,000 employees now. So that was a introduction regarding like what we have been doing, and okay. So what we have been doing and what we have been deploying for the customers. Now I'll give you a brief introduction of what we are trying to do. So the things that you've just seen, like what we have done and what we have deployed. I'll get into the robots that we are building for the future, or maybe we have started launching, we have started developing it. So one by one, I'll go through them. So first one is the cobots.
Rajesh,
Yeah.
just sorry for the interruption. Can you just press on that hide? It's actually hiding some of the content. Stop
Okay.
sharing and hide. Yeah.
Okay. Yeah. So I'll start with a collaborative robot, which is also called as Cobot. So this is this talk also is focused. It has a name Cobotalks, which is, so cobots are primarily used for a term when the robots are collaborative. So collaborative, we mean that they should be collaborative to human beings. So for people trained in robotics, people can understand this is a 6 degree of freedom articulated arm. It's like 6 joints and all. So, but it's different from a normal robotic arm in the sense it means a robot people tend to be away from, right? It's like if the robot is doing something, you tend to avoid it because it can harm you and all. But these, we call it collaborative robots because if you touch it, even if the robot is in motion, there are numerous modes. Either it can be collaborative mode or safety mode or whatever. So at lower speeds, when the robotic arm is moving, you tend to push it. Yeah, means if the human wants to push it, the human is able to push it. It will not be restrictive. It will not be like, okay, I'll follow my trajectory. So they are more, as you call, in a layman terms, it's human interactive the real sense. We can put it into human safety modes as well. It's like when the robot is doing its task maybe at a higher speed now, and if it moves and you touch the robot stops. So basically means we have been building different kinds of these, the carbon fiber system, the metallic system, and we have been doing all this all types of like control planning and like vision based architectures over it. So this the smaller cobot that we have been building is around 700 reach 5 kg payload. uh, and the biggest thing is it's not, it's like, as I just said, it's collaborative to the human, so it can be used. We are trying to also expand our horizon and put it into medical use cases where it can touch the human skin and do tasks where the necessity of a doctor is not or the expertise of a doctor is not required, maybe physiotherapies or maybe ultrasound, teleoperative ultrasound. It can be used as well. So safety is a big thing in these robots, especially when we have to put human in the loop. So the stopping time has to be put into perspective, and there has to be dual what do you call it, redundancy in compute modules, redundancy in the safety architectures and all. So those are things that have to be implemented. So we have both the operations available. One is the normal operation and one is a functional safe operation. Functional safe operation, we call it as SIL 3, which is like a safety, a gold standard when we get into medical use cases. And again, it's a robotic arm, so we have been using it, we have been putting it into use into standard pick and place industrial operations where it can do bin picking. You place camera over it, uh, run a detection module, it can detect which object it is, can empty bins, place it into another point as well. So, and also I'll tell you later, we have been also building haptic devices of our own, so it can be semi-autonomously controlled using a haptic device. Also, we have been so these robots we have launched and trying to do pilots with different universities and different people. So the robot that we are building can do like can be used into medical use cases, as I just said, can be used in radio imaging. They can place either vision assisted or non-vision assisted, can be autonomous. So as you can see, the purpose of this talk was to say, okay, my perception classically we used to differentiate, okay, my robot can do certain planning, algorithms have to be implemented, some perception has to be implemented and all those things. But now we are at that regime where the boundaries are very fuzzy. For example, if I do want to do a vision assisted pick and place where the robot has to be interactive to the human. So it's like my goal position comes from the vision, but then my optimal path comes from a like, for example, an RL controller or maybe a motor an MPC or something. So those boundaries and all are getting more fuzzier, and we are also trying to put make the cobots more intelligent. We are working on that so that they can respond to voice and all. The other thing is an industrial cobot version, which is like the same cobot but a bigger one and much quicker. There's a 10 kg payload, 1.3 meter reach. It's again a 6 degree of freedom articulated arm, but it can like take much higher payloads at much higher speed. So it's primarily based for industrial applications. So as I said, we have been also been building haptic devices, which is like a joystick. As you can see, for people trained in robotics, they can quickly understand it's like a stable platform. It's like it does like the job of a joystick. You move it, the robot moves, but it does another thing. It's like whatever force the robot, or maybe in a virtual reality scenario, we have been developing some game engines and VR apps over it, where whatever is happening at the remote end can be felt on the robot as well. So again, we have been doing some pilots with this as well. So one of the application was controlling the neck exoskeleton, where so this is a very critical sense where the haptic device, if it moves, then it has to move the human neck, and it can be very critical. If more force is applied, then it can cause injury. So the force, whatever restriction the human feels, is being felt onto the haptic device, and the uh, user who is holding the device can feel it and then can manipulate whatever is seeing, and also he'll be seeing whatever is happening on the remote as well. So a human feeling the force, viewing what is happening at the remote end, makes a decision, and there is a semi-autonomous layer which has to be implemented on the exoskeleton end as well to ensure safety. The other thing we have been, so this thing we have been doing with IIT Delhi itself, with Bharati School, where we have been trying to implement haptic interfaces over 5G, which is like a haptic glove, a robotic hand, and the haptic glove has to manipulate some object placed on the robotic hand. And then, so this is not with our hardware, but the software understanding was then how the data would be get compressed into a form so that it can be transferred pretty quickly over the network. So the bandwidth have to be understood, and how to compress the data so that there is limited loss of the haptic signal and also there is enough reconstruction. So we have been doing this. Another use case of a haptic device is a virtual reality environment or training for that sense. So that is also what we have been doing. The other thing also, as I said, that we are trying to get into fields which are actually human collaborative and human interactive. One of them is exoskeleton. Very similar technology to a cobot, but the only thing is the robot is lighter and it's wearable. So it's a robot which you can wear. It's like a school bag or something which you just wear it and put your arm within this joint. So what it does is it performs, there are different modes of performance. One is like complete rehabilitation sort of a thing where the person is not able to move its arm on its own. Then there are some rehabilitation exercises, rehabilitation tasks that has to be performed, so the robot will take full control. If needed, if the human doesn't feel comfortable, then you can hold it. The robot will not unnecessarily push it into the trajectory if the human wants to use it, hold it. Another mode is like sort of an assistant sort of a thing. For example, you have to do a repetitive task, but you don't want to feel the weight of the object and your arm itself. So it's like it will make you feel massless so that fatigue is reduced. And the third mode is assistant. For example, you have to do some repetitive task and want the robot to take control. So these are things that have been working. And the other thing that it's more towards, so we want to get into legged robots, so and ultimately humanoid. The first thing that we have started with is a quadruped robot, which is a a four-legged robot. So this is the second version, which we are doing pilots, trying to do pre-pilots with defense and other institutions. Is like, so these are walking robots. So it's different from a mobile robot because it can go into terrains which are uneven. It can walk through and like based on the same
कोई बात नहीं, क्या करूँगा, कोई फायदा नहीं आएगा।
so based on the control
आज और
architecture,
चेकिंग हो
where it's required, it can climb stairs, it can have autonomous navigation, and also these are 12 degrees of freedom systems. So we are doing pilots with a smaller version of this, which is around 500 big robot. We are building a bigger one as well. So the target is initially surveillance, and then later when the payloads increases, the primary target is helping load transmission in uneven terrains. So again, as I just said, it's primarily a combination of all. Means if you see a legged robot, where it moves, how it moves, is not just generated by a controller, it's generated by the perception says you, okay, you have to be there. If it's a stair, then you have to place your feet at a particular point, and then the controller places the feet. So it's not that a single module does one thing, another module does something else. Everything is now interlinked. It's like our controllers that we have been building, they primarily use a lot of perception data to generate commands onto the robot, where to walk, how to walk. Same with the cobots or the haptic devices as well. So yeah, that was my brief understanding of what we have been doing and like where does the future lie. According to me, it's primarily whatever you do, a robot has three modes. Like it has to see something, it has to act, and it has to plan. For example, move from point A to point B. How would I move based on what I see? Now the question is, and it has to have a hardware. And with the advent of something like a VLA, which is like language assistance and all, which we say language is another thing, what the humans speak. So these are the four modalities. You have to combine it to them and just ensure that the motors rotate so that they do a particular task. So we have been working on different robots, as you've seen, a mobile robot, collab, anything which walks on ground, basically. Yeah. But the whole encompassing picture remains the same. It's like there's a set of motors, a task that has to be achieved. The robot sees something and it has to act via a set of either equations or it can be trained. And the equations normally now they do not directly use. Means earlier it used to be you see something, then you go, then you, for example, have to go to a point, you see, okay, which point you have to go, and then based on the obstacles that you see, you move. But now my controllers inherently use my perception information as obstacles, or maybe they are trained in that environment per se. So that's, I think, all for me. And now I'm open to questions if there are any.
Hi Rajesh, can you hear me?
Yeah, I can hear.
Yeah, wonderful talk. Yeah, just a small question. So I understand that using vision, it would help in perception and planning because more or less like they both combine to form a reasoning region for the robot. But like, how do you like plan to combine the controls aspect as well, like using the feedback and then giving it to a vision model or something?
Yeah, so one thing is, for example, when you talk about model predictive controllers, optimal controllers, for example, right? I'll give you that example. Now the question is, I have two ways of doing it. Either I create my controller and my planner gives my base trajectory and I ensure my robot moves in the particular trajectory. Or I give my vision input or maybe the obstacles directly into my controller on optimal controller as constraints. Now my controller will directly do the higher level planning. My controller will also do the lower level planning. And because the planner, see, what I'm doing is pretty much the same thing. It's like, and now I am just also encompassing my vision information as a constraint or as a modality. Same with speech also. For example, if I, with the advent of GPTs and all, if I also give a speech input, for example, I've given a vision input, like for example, a robotic arm has to pick something. So there is a goal point or a goal object that has to be achieved. Now there are certain obstacles around. Earlier or normally what now anyone would do was do a planner, run a planner, and you have a baseline controller and ensure that the obstacle is avoided and all. But ultimately what you're trying to do is have your controller, or maybe the thing that we do in MPCs or reinforcement learning methods, or maybe in language assisted methods, is like we have those constraints. The constraints contain the visual information as well. So that becomes my obstacle. That's becomes my constraint in my MPC. And also my a particular modality of my vision input or my language input. So that's one of the same thing.
Okay, thank you very much. So people who have questions can also raise their hands. So Rajesh, maybe I have one question. So you mentioned about NPC, right? Hello?
Yeah. Yeah.
Am I audible?
Yeah, you are audible.
Yeah.
So Like, how do you handle dynamic constraints there in your algorithm in MPC?
No, so dynamic constraints. So normally, I cannot. Okay, so normally what we do is, so there is a local representation of the dynamic constraint, right? For example, an object is moving, or when the object passes by, right? So there is the constraint would have an approximation, in the sense we have an estimation of it. Like for example, there an object is moving across it. Now the question is, does it affect my base constraints or not? If it does affect my base constraints, then means I cannot tell you exactly, but if it does affect my base constraints, then I would have a set of uh, I'll modify my cost such that it moves away from it. For example, I'll modify my field, which is the cost function, such that the if my cost function is directed towards the dynamic constraint, then I'll have a higher cost which pushes it away. So everything is so. One thing we normally do with MPCs and RL is like we don't try to get into complete optimality always, because because things have to run at a higher frequency. When it's running at a higher frequency, we cannot achieve complete optimality as we do in an academic scenario. We tend to achieve complete optimality always, right? We want to, okay, my system should converge and there should be this thing. But here what I'm trying to do is, at every step I'm moving away from my system, for my systems which give me lesser reward, or which makes me more suboptimal. So if a dynamic obstacle or something, or dynamic constraint comes up, I'll have a convex bound over it. I'll just have a convex approximation which can be quickly created. It might not be the most optimal one. For example, I can, for example, even if it's a non-convex system, I can just bound it with a sphere or with an ellipsoid or something, and then have update my potential field such that it moves away from it. So that's how we normally handle. We do not tend to update in the most optimal way, because we don't have we are like normally constrained with both resources, the computation, and also we have to ensure high update rate. So it does happen, and there are safety layers ultimately, even if certain things go wrong, which are rare, because we have those we have our own boundaries pretty large. We do not work in very constrained environments. So even if certain things fail, then we have our safety regimes which stop the robots, basically.
Okay. So you mentioned about the hardware requirements. So do you think that going forward, you will need an advanced hardware, GPUs, or this will work out?
So by hardware, I meant by compute. So
Yeah.
see, ultimately, cost is one thing we have to maintain with the robots, and ultimately, I cannot predict. For example, if you ask me, so if it's a cobot and there are like 100 different dynamic obstacles start coming, then how quickly can you give a path? For my particular application, I might not even think of that, because no application of mine currently would want to deal with 100 dynamic obstacles moving here and there. So right now, the uh, hardware, or maybe the GPUs, if you go into learning, or maybe the quad core processors that we use do suffice for our requirements. But then if you say, what if the number of obstacles, constraints, and all those things increase, then what? Then we might need to think. But that don't think has happened to us. One thing we do with this thing, with our fleet management system, where we have to optimize the routines for like 100 or 150 robots, then it might happen. But then again, we do not go into complete optimality. Even if it's even a feasible solution which is not optimal, we are good to go with that normally, because cost is another big thing.
Okay. Thank you. So, any other questions?
Okay, thank you. Any other question? Please raise your hand. Rajesh sir, could you also put your email ID in case any question the attendees have later on in their mind? They can email it to you and ask you their queries. You could probably give it to
Yeah.
us the chatbot. Yeah, that's rajesh.kumar01. You've given that already, right?
Yeah.
rajesh.kumar01@adverb.com. So guys, you can note that down. Any other question? Kindly raise your hands now. Or we shall go ahead with thanking sir and closing the session. Okay, somebody else has raised the hand.
Yeah. So can you hear me?
Yes, sir.
Yeah. So as a mechanical engineer, what key skills do you look into if you want to take part in the Adverb uh, company?
Okay. So I take care more on the software side, but I'll give you an idea for the mechanical design thing. We have two basic domains here. One is the warehouse automation domain, and one is the R&D domain. Warehouse automation domain, where we handle big projects like greenfield, brownfield projects. So there you should have idea. If you want to apply there, you should have idea about the industry standards, the components that are readily available, which can be directly deployed. The good understanding of machine design should be there. When we talk about core robotics R&D, the thing that in the later half of my presentation, we focus more about on understanding of kinematics, little understanding of kinematics, little bit understanding of
Right.
carbon fibers, machining entities, 3D printing, and
Right.
harmonic gearboxes and all, basically.
Yeah. Okay.
Okay, great. Anybody else? Okay, I would now like to request Professor Saha to kindly give away the 150 euro Springer voucher to Rajesh sir for today's talk. Can we have the voucher on screen, please?
So anyway, thank you, Rajesh, for sparing your time and explaining all the development at Adverb. And
Yes, sir, there it is.
yeah. So Rajesh, please accept this voucher of 150 euro from Springer, and we'll let you know how to encash this thing to buy their books, Springer books. So please accept it.
Sure, sir. Sure, sir. Thank you,
Thank
sir.
you.
Thank you, sir.
Okay,
Yes, sir.
yeah, I'm done.
We'll be sending, yes, thank you, sir. We will be sending out a letter, sir, to Rajesh, sir, and we will explain to him how to go ahead and redeem it.
Okay, are we done?
Okay, yes, sir.
Thank you.
Thank you so much. Thank you so much, Rajesh, sir. Thank you for your kind time. And the rest of you, thank you so much for joining us today. Have a wonderful evening and a great Rakhi and a weekend ahead. Thank you,
Thank
everyone.
you. Happy
Good
Independence Day
night.
to all of you.
Yes, yes, yes. Tomorrow is 15th August. A very happy Independence Day from
Oh,
IHFC family to yours.
bye bye.
Okay, good night. Thank you. Bye bye.